Hello, everyone. I'm very honored to be presenting at the 6th International DLA at the Southeast University in Nanjing. And first of all, I apologize for not being there in person. In my presentation, I would like to provide an insight into my research and explain how digital models can help us design large-scale landscapes. I will show two examples for which digital models were instrumental in the design process. But first, I would like to take a step back for a moment and look at this picture. This is called the Earthrise and was taken from the Apollo 8 mission in 1968. It is considered to be one of the most influential photographs ever taken. The American politician Al Gore shows it in his 2006 documentary, An Inconvenient Truth, to explain the fragility of our Earth system. Since that photograph, remote sensing, digitalization, and computation have greatly advanced our understanding, as shows this data visualization. Here we see the interaction between carbon sources, shown in brown color, and the carbon sinks blinking in green as daylight activates photosynthesis. As we all know, the sources outweigh the sinks, and this animation visualizes the carbon surplus that remains in the atmosphere. At the end of 2021, it almost reached 38 gigatons. Now, what the Earthrise picture of 1968 doesn't show is how thin the living habitat is. Almost all terrestrial life depends on the near surface environment and its metabolic functions, also called critical zone. The soil is often just 80 centimeter deep and enable all the exchanges of nutrients, agriculture, water filtration, or carbon sequestration among many other ecosystem services. However, the territory transformed massively and rapidly in the 20th century. In this image, you see time steps of urbanization around Zurich in the last 120 years. Wetlands are drained, soils are sealed, the territory is artificialized. The consequences are well known. A few centimeters of altitude can have impact on kilometers of distance. Many recent events, like this catastrophic flood in Germany, indicate that measures of mitigation might soon be outpaced by measures of adaptation. So the question is, how do we relate these large-scale phenomena to very small details? This is why we work with high-resolution 3D point cloud models. These models are made of millions of points and are recorded with laser scanning technology. Laser scanning documents with centimeter precision the shape of our critical zone. Here we see a moving section that reveals the detailed form of the urban landscape. It spans from the dimension of small earthworks, vegetation, and built forms to a higher, bigger system, to the dimension of mountains and glaciers. The geometry of any territory can be represented in 3D point cloud models. This surface is where the terrain interacts with all states of water, liquid, solid, like this image, the Silvretta Glacier in this image, and also water vapor. Indeed, raising humidity and temperature pose serious health threats to people. Measured information can be geolocated on point cloud models and reveal microclimates in the city. In this image, the color represents temperature around the main station in Zurich. Even at low sampling, we notice that shading effects of the station roof shown in blue in this image, or the hot spots of the mineral ground in red. The precise geometry of point cloud models also helps understanding dynamic conditions. The near surface environment determines thermal comfort. This image shows an urban landscape in Singapore, designed by students from Singapore and ETH Zurich. The configuration of buildings and vegetation was tested with a wind speed simulation for thermal comfort. Now, to further explain the use of digital models in design, I would like to show an ongoing design study that we have in Madagascar. The capital of Madagascar is called Antananarivo and is exposed to monsoon rain, which represents both a risk for people and, of course, a benefit for crops. The point cloud model helped us understand the detail of the site, such as the micro topography shown in colors in this image. For example, all the arrows that you see here indicate breaches between the closed polder system, that means these entities with dike rings, and the two open river systems here, the Sison River and the Yiqiu River. Now, let's zoom on the arrow that has the cycle around it. And here we are still inside the geolocated point cloud model, and we see the tiny passage in the center that is represented in this point cloud model. This tiny passage you see just in front is a sluice gate that manages all the exchange of water between the outside river system and the inside polder system. This gate is only 70 by 80 centimeter wide. This interscalar perception through the digital model also extends the comprehension of interrelated dynamics. We used flow simulation to understand the behavior of the current topography. In this animation, the flow simulation reveals how the water moves between the different rice paddies. By understanding the water flow, students were then capable to design precise topography at large scale. Here, transformed topographies are iteratively tested and improved with flow simulation. Here you see the flow simulation in white. All the terrain has been shaped with a depth difference of less than 1 meter height from the original terrain. The second examples show that the design method is also operational and can be applied in practice for award-winning projects. This is a competition for a bridge over the Qinhuai River in Nanjing that we won in collaboration with architect Christian Kerez, professor at the ETH Zurich. As the landscape architect of the project, I worked with a precise 3D point cloud model. It provided the necessary base to understand the existing site. The image on the left shows the elevation above ground from the lowest points. So you see these lower canals in blue to the highest points, the dikes shown in red. On the right, you see the vegetation patterns and the built infrastructure, all represented on the 3D model. So this information, the 3D point cloud model, helped me understand precisely how the site is composed. Sections can be generated anywhere within the model. And you can see here in this image, the extract shapes along the dikes on the Qinhuai River. Then with the model, we can also zoom to specific points that can be analyzed from close up. focusing on specific parts of the site, like the wetland or the dike, or also the park amenities. For example, looking at point number 1, the point top left, we can see again a passage from the inside of a dike to the outside of the dike, exactly like in Madagascar. The next image shows the same point number 1 from a higher view. And we can see how a pumping station behind the dike evacuates the water from inside the dike to the outside wetland and river system. In this image that shows the before and after of the topographic transformation, here the topography is shown by altitude. On the right is the topography of one of the variants during the design process that copes with the very specific landscape of the bridge on the on how the bridge lands on the terrain. And based on the request of the client, we worked strongly with the context, trying to maintain the existing wherever possible. Therefore, I designed precise cuts into the pointed model by deciding then which trees should be kept or which trees should be removed. Then the design proceeded through several iterations where we discussed how the bridge should be connected to the landscape. Here on this image, the bridge actually extends through the landscape. And we continued this idea through different steps and decided to weave the path into the existing site. Here's just another visualization where the new vegetation that we imagined is arranged in cycle patterns around clearings. And this is the final result of that was presented in the competition stage, that shows how the bridge is anchored on both sides of the river landscape. So this was my presentation, and I hope that I was able to give an insight on how the point cloud modeling technique can help design projects. Here's a link for my, if you are interested in further publications and information. Thank you so much for your attention.